So if we have a Wheatstone bridge setup, but now all four of our resistors are strain gauges. All right, so all of these are strain gauges. All right, um, we can still say relate our output voltage is still proportional to the resistances of of our each of those resistances. All right, so when this strain gauge undergoes an applied load, the values of the resistances are going to change in each of the strain gauges. Okay, so there's going to be a change in resistance due to R1, R2, R3, and R4. All right, so this is going to cause a change in the output voltage that we're measuring across the bridge. All right, so that change in output voltage can be measured using the following equation that's shown here. All right, so if we make some substitutions here, so we say that all the dr terms we can substitute with the original resistance times the strain times the gauge factor for each of the strain gauges. All right, and we can make the assumption that the change in resistance is much less than the original resistance of our gauge. So our change in output voltage due to an applied external load will be given as a function of all the initial resistances, all the original gauge factors. Okay, so if we have all the resistances are the same and if all the gauge factors are the same, we can simplify the equation a couple times here, and we get this equation here for our um, uh, total our expected relationship between our output voltage, our input voltage, and the strains we're measuring within each of the bridges. Now, the one thing you should notice is that the signs of the within this equation. So, if we have equal strain in strain gauge 1 and strain gauge 4, which are across from the bridge, they get added together, while the strain gauges that are next to each other, alright, like strain 1 and 2 and 3 and 4, they are equal, they are opposite of each other. Okay, so we're going to use that factor that feature of the Wheatstone bridge in a second in order to do some neat tricks to deal with changes in temperature that are experienced by the Wheatstone bridge, and also to add or subtract unwanted effects due to undesired loading from our on our Wheatstone bridge. Okay, so um, what's the last thing we're going to talk about in this video is something called the bridge constant, which is we denote with the Greek letter kappa. All right, so this is the ratio of the actual bridge output compared to the output of a single gauge, uh, a single Wheatstone bridge with only a single gauge that would be outputting the maximum strain. So basically, it's the same equation that we developed for a single gauge, but instead of having um, just the just this term here, we add the kappa term. All right. So this kappa is typically a known constant, uh, and we'll talk about how we can calculate kappa during the next example problem.